Hi everyone, my name is Ryan Booz. I'm a developer advocate here at Timescale. And for Timescale Tuesday this week, I'm continuing on a new series about creating sample data. Now, I'm going to talk about the first of the four things I discussed last week, the four ways that we tend to create data here at Timescale when we're testing Timescale, when we're helping users or potential users investigate Timescale with time series data, trying to understand if it will satisfy the need based on the kind of data they have. Often it takes a lot of work to use your existing data, find a way to get it into a database like Timescale, and then do the queries that you want to do. So knowing how to use tools like Generate Series is really valuable because it allows you to test maybe your specific use case before you go to all the work of creating and moving your data. Or maybe you hear about a new feature and your data doesn't specifically satisfy something that you could use that feature for, but you want to play with it. And this is a great way to use something like Generate Series. So this is going to be an intro. As I was coming up with the SQL I'm going to demonstrate today, I realized there's so many things you can do with it, so many ways I've learned to use it that it's at least a two-parter on Generate Series alone. So this is going to be an intro. Hopefully next week I'll be able to get back to this and talk about a couple of advanced use cases so that you can really start to do some complex stuff. So let's go ahead and get started. If you have used Generate Series, this might be a little bit rudimentary for you. It might not be though. If you mostly have only ever copied and pasted data or examples out of maybe our documentation or Stack Overflow, something like that, stick around. This might be a way for you to better understand exactly what's happening with those examples in Generate Series. So first, let me show you the documentation. It's straightforward. It is in the Postgres. Again, this is a Postgres function. This is not a timescale function. And it's really straightforward. The thing that this documentation doesn't really get into is some of the ways that everyone uses it and what's really happening when you're generating multiple versions of series. That's what I'd like to show you today. So let's get right to some SQL and look at what this might mean for you. So Generate Series allows you to go from one value to the next. So it can be used with numerics, integers and numerics, or it can be used with dates and times and timestamps. And so in this very rudimentary example, I'm saying generate a series of data from 1 to 10. And that's exactly what happened down below. Now, you can provide a third option to Generate Series, which is the step value. What are the increments from one value to the next? I start at one value. What are the increments I'm going to go to? In a numeric function, if you give nothing, it's going to increment by 1. Or you can provide a value. In a timestamp Generate Series, you must provide that interval, that step function as an interval so it knows how to create those buckets. So in this example, I'm going to go from 0 to 10.5 in increments of 1.5. And you'll notice something that I don't actually see 10.5 down here. And that's because these numbers start and end, the first two values, are inclusive. So you'll notice that I got to the number 10, and if I add 1.25 to it, it would actually get me to 11.5, which is beyond 10.5. So this doesn't mean you're always going to get the ending value. You'll always get the first value. You might not always get the exact ending value depending on what your increment is. So that's many ways you can play with that with whole numbers, values, numerics, and so forth. Now, if I do it with a date or a timestamp, again, this is inclusive. It's from January 1st to January 2nd. I'm going to create intervals of 1 hour. So you'll see very much like a time bucket in Timescale. For that date, you'll see I get hour increments. And as I said, this is inclusive. So I also get, as long as the interval falls in line with that inclusion, since I didn't provide a time, it's going to default to the beginning of the day, which is 000. And so in this case, I actually get 25 rows because I did hour increments starting at the top of the hour. And so I get a total of 25 rows, not 24, which may or may not be surprising to you. Now I can shift that time, right? So not only could I produce an interval or step by an interval that's maybe a little bit unique, it doesn't have to be a whole time like an hour or a minute. I could do 2.5 minutes, for instance, and eventually I would maybe not hit that ending hour. But the other way you can do it is you can actually provide in your starting interval, I can offset it by some amount of hours or minutes. So in this case, I'm starting at 10:02. And so if I go by hour increments, I'm going to get values at 10:02, and then 11:02, 12:02, and so forth. A lot of ways you can produce interesting data. And again, next week, we're going to look at ways that you could actually even do random data within random data, random times and random lengths of data and so forth. A lot of cool opportunity to produce value and data for you to experiment with. So what's really going on here? That's all well and good. That's very easy to understand that I'm getting a table of generated data from this function. But in a lot of the examples you see from us, when we talk about time series data, you'll often see at least 2 different tables of data being selected from, and you just start to get this magical table of data for what you need. Well, here's how it works in Postgres and most SQL variants. When I select 2 tables of data, whether they're real tables or what we call generated data, tables of data, when I don't join them specifically, I get what's called a Cartesian join. When I say just select everything from everything, I'm going to get a product of both tables put together. So in this example, I'm simply taking an array, I'm unnesting it. What that does is get me 5 rows of data, and I'm going to simply select that with a generate series of time with 1-hour buckets. And you remember this got me, this exact interval above got me 25 rows of data. Now, if I join that with something that has 5 rows, I should end up with 125 rows of data. So just like that, I start to produce a lot of data, which is pretty exciting. And so what you'll see here is we get 1 row of generated series for every row in the previous table. So I see a lot of values of 1, and then I see an hour incrementing beside it. And you'll see eventually I'll get to number 2, and we start over again at the top of January 1st. So hopefully you start to see how we can use this for time series data. Now, in a lot of our fake examples, what we'll do is something a lot more straightforward and honestly a little bit easier than something like unnesting an array. We can just use 2 generate series, right? We're going to get 2 different pseudo tables with lots of rows in them, and we're going to do a product of the 2. This ends up giving me the exact same data as the one above. It's just a little bit more straightforward, I think. So now when we do that, we can see, there's one other example I meant to show, which is interesting, and you'll see in a minute why this could be useful and valuable. At least I think so. You don't have to select all the columns, so you can actually get what looks to be this kind of repeating effect, or many, many rows of something without showing all the information that's going on behind the scenes. So this is one way that I could get the string hello world to repeat, in this case, 5 times. I generate a series of data, 5 rows of data, 1 to 5, and I simply select hello world, really join to that essentially, and I get hello world repeated 5 times. What's really happening behind the scenes is you'll notice that I've aliased this generate series to a value of T1. And so what's really happening is I'm getting this behind the scenes. I'm just not selecting that column. So this is a way to repeat information. There's other ways to do it. I just thought it was an interesting way to show you with generate series. Now, one last thing that you'll see, and this takes all of the things we've talked about so far, and now it starts to get towards your real data. One way that people often use generate series with time, particularly with something like Timescale or just regular time series data in a Postgres in some way, is there's often times where you want to get a static bucket of time, an hour for every hour of the day, per day or for a month or something. But you want to make sure the row always exists. Maybe you're going to chart it, right? And in a lot of charting tools, if you don't have a row, you get an empty spot in the chart. And so you want to make sure you have a row for every hour, even if there's no data to aggregate for that hour. So let's say you have sensors and they're counting the number of people coming in and out of a room in a building. And at night, there's not many people coming in and out of any room, maybe the janitors, maybe some visitors, maybe it's a hospital or something. So there's a little bit of traffic. There might be some hours where a room has no people entering or exiting. If you do a simple aggregate based on time, in most cases, you would end up with missing rows of data for some buckets of hours that have no data. So this is one way that people would come up with a static set of buckets of time. It would then use that table to join to your other table to do your aggregations, maybe sums or averages or counts or what have you. And so this is a culmination of what we did above. We're generating a series for, in this case, I picked January 20th to the 21st. I don't know why I did that. And then I am cross-joining it, so essentially doing that Cartesian join, and I'm actually getting distinct sensor IDs out of my real table now. now I'm not generating fake IDs. I'm actually using my data, and it looks very similar. This looks exactly like what I had above, but those IDs are actually IDs from my table. I could put other qualifiers on here. Notice I have where sensor ID is less than 10. Maybe I just want the IDs for a specific portion or floor of my building. And so now I can get this bucket, each individual hour for just those specific IDs I need, and then start to join that to other queries and other tables. There's a lot of ways to use generate series to get time series data, and it's not always just to generate fake data. It's really useful for selecting into other tables and other aggregations. The last thing I wanted to show you before I get to one real life example is to walk you through a more complex example. I thought this might be helpful to see how, as you join each of these tables together, you multiply the rows. It's not just about creating a lot of data, it's also about being able to group it and aggregate it in a way to do something unique. So in one of the examples we'll talk about next time is creating fake text. You know, there's a lot of our time series data that does have stuff other than just numerical measurements in it. And so if I wanted to create some sample realistic data, at least in size, I could do something like this. Now this is a Stack Overflow post. Had a lot of examples. I was trying a lot of them. I like this one because it used generate series. And so when I do this, I get 10 words that are all 50 characters in length, and it's random, right? So I'm getting various amounts and types of data. I could make the string appear anything I want. I just happen to use this string. Now what's happening is I'm generating two different tables of data, one that is 50, there's my 50 characters, and then one that is 10, that is my 10 individual words. Now how is this working? I thought it'd be fun to break this down briefly for you so you might be able to see again how you piece these things together. So the first is we're simply taking a string and we're selecting a random character out of there. That's it. That's all that's happening originally at the top of this query. Then we join that, so we get one value, we join it to generate series, and what actually happens there, because it's a join, that substring is going to get called 50 times. I'm generating 50 rows of data, and for every row, it's got to go get a new character from that string. And so sure enough, that's what happens. I get 50 rows. Well, now when I add on one more series of data, you'll notice I'm selecting the series down here, and I'm showing you what's coming from those series by selecting those columns out as we do it. So now when I generate these two things together, I have 50 characters and then 10 more rows of data. That's going to give me 500 rows of data with unique values in each column. So now you'll see the IDX. So this gets back to what we did up top. As we keep generating and adding these things together, you'll notice that IDX only moves every 50 characters. It increments once I get to 50, and then we start over again. So how could I use that to generate those 50-word characters? Well, now I can use some aggregations. So if I use the built-in Postgres function string aggregation, I can say, hey, aggregate all the characters together that share this specific thing in common. And if I use that third column that I'm displaying right here, if I use this column, it's going to group every 50 characters into one string. And sure enough, that's what happens. So it's really interesting how you can start to use all these things together to generate data that could be useful for you in better understanding timescale specifically, or just other parts of Postgres. So I wanted to get to this one last example then and talk about how I end up using this when I do these videos, when I help customers, when I'm looking to help someone with a problem and I need a lot of data quickly. The first thing I need to know is how much data am I going to generate? Am I going to generate 1,000 rows or 1,000,000 rows? And how do I do that? So I'll often take a query just like this. And this is two generate series together. One is a time bucket, essentially the buckets, the date time interval. And one is just some fake IDs that I'm going to end up querying on. And so in this case, I'm doing a 1 day of time, 5-minute intervals for 100 items. And if I run that and I count it, I see that, okay, for 1 day of data, if I did 5-minute intervals, I'd get about 29,000 rows per day for 100 items. And I could start to change that. You know, if I make this 1 minute readings, I'm not going to do the math, so I'll just do that quickly. I get 144,000 rows. Maybe I do it for 1,000 items that I'm reading. What does that get me? Well, you do the math, that gets you 1.4 million rows. And then you can start to see what happens. What if I make this 30 days? And you can start to see that without a lot of effort, you could very quickly get a lot of data. So 30 days, 1 minute readings for 1,000 things, and all of a sudden I'm at 43 million rows pretty quickly. Now you will notice the more data you generate, the longer it's going to take because it's actually all happening in memory. You'll notice I have not referenced a table anywhere to insert this data into yet. And that's one of the reasons I love Generate Series. You can do all of this without having anything created yet in your database and get an idea of the data you're about to create to make sure it's what you need. So I know we are 15 minutes into the video. I wanted to show you briefly what we're going to do next week and how to make this a little bit better. This is the example we give in the tutorial I showed you last week. If you go to our website and you look at tutorials, we have one called Simulate IoT Sensor Data. This sensor data this is the query that we use, and it generates some random data. You'll see everything we just talked about. I'm generating a series of time buckets, 5-minute readings for 1 day, and then for 1,000 items. There's my 1.4 million things I'm generating. Now, if I want to make that a little bit more realistic, this is one thing I don't like about that example, and I just need to improve upon it, quite honestly, is these aren't very realistic values, and they're super high precision, which I don't know anyone that's measuring their CPU to 15 increments, 15 decimal places of precision or more. And so, you could start to do something like put them within a range of data, right? I just don't want a random value. I want CPU readings between 0 and 100. And this is kind of a proven way to do that. I'll talk more about this next week, but I take the high value I want, subtract the low value, and then add the low value back. When you multiply that by random gives you a number between 0 and 1. You're always going to end up somewhere just a little bit north in most cases of that minimum value at least, and probably a little bit south of the high value. And so now at least these values start to look a little bit more realistic. I actually looked up CPU temperatures and said, hey, a general good value in Celsius, anything above 83 Celsius and it's probably screaming and you need help. At rest, 20 is probably a little bit low, but something to measure with. So now I have data that's looking pretty decent. And finally, I might maybe do something like round in floor. You'll notice when I round this number, I actually have to cast it to numeric. Round uses numeric. These numbers all are a type of numeric, so it's easy to do that casting. Now I'm starting to get temperatures and CPU readings that look a little bit more realistic, like something I could actually graph and start to see something, even though it's still random data. And so with that, this gets you to exactly what we have in that tutorial. I can create a table, which I've already done. All right, we have this in that example. I make it a hyper table. Now I'm going to truncate this because I may have already put data in there. And then I'm going to go ahead and insert exactly what we just did above. And you'll see it's going to take a few seconds because it's generating 1.4 million rows, inserting into the database. And then we get our 1.4 million rows. There we go. And you'll see that pretty quickly, I have fake data. And now I can start to run queries. And that took me, honestly, not much time at all to make it something a little bit more specific to what I wanted. And, I could run a simple query as we have in that document, getting time buckets. Now I'm actually using Timescale, using the functions we provide to start to see how this works. So that's where I wanted to get to today. And as I said here, it's to be continued. There's more to dig into. I want to show you how you can go above and beyond to create more realistic random data without a whole lot more effort so that you can really start to think about, hey, my example is 50 million rows per day. What does it look like in Timescale to generate a hyper table that has 10 columns and 50 million rows? Well, I think if you could start to do some of this, you could do it in a few minutes and pretty quickly start to understand how Timescale works for you before you go to all the effort of moving your data. So let me go back and we'll finish this up for the day. We already looked at the SQL. Please subscribe to our Slack channel if you haven't. Come join us there. I just love continuing to meet more and more people, seeing who is helping one another. Subscribe to this YouTube channel. We will continue to show you more and more of these examples, and I'm going to continue this series and much more. There's so much going on. You're going to see announcements over the next couple of weeks of some really neat new features. We're getting ready to update our docs. You'll see a new version of our docs. There's just a lot happening. Please provide comments of how we can provide more content for you, whether it's Postgres based or Timescale based. We just want to be helpful. We want to see you succeed. And hopefully this is a good way to start to use Timescale, generate some data, and see how these functions work. Thanks so much for watching. Take care, and we'll see you next time.